Hello everyone. I just wanted to make another quick video. At least I hope it's going to be quick. To share some more thoughts about CICO, or rather the line of reasoning that would try to ground CICO in physics. I would like to share first two conceptions or two kind of arguments which have been used to oppose this narrative that physics is going to somehow entail CICO. So the first line of argument that has been put forward is a one that at least I would see kind of well done with Bart K. So here the argument is kind of twofold. So it's a two kind of step argument. The first one consists in kind of showing that most of the time CICO proponents in the fitness industry or even sometime actually in the physiology and nutrition industry basically don't know the laws of thermodynamics. And so, to some extent, if you don't know what you're talking about and what you're invoking, what even are you referring to? So it's a quick way really to kind of show that there is a problem. Now, of course, there is a more, let's say, tangible version to it, which is that then one would state, a formulation of the first law of thermodynamics, and in particular, Bartke insists that there is only one formulation, and that's the one that he provides. And this is an interesting discussion to have, of course. I mean, personally, I disagree with this view, but in any case, what matters to me is that we stick to one particular definition, and then we can move on to something else. In any case, the idea is to say, well, the definition that Bartke is using, for example, requires, that's really a strong requirement, that the system is closed. And in this case, if the system is closed because human bodies are obviously not closed system, then it doesn't work. So period, the discussion is closed and nothing to talk about. So that's kind of the easy way. I mean, not the easy way. I mean, at least that's a quick way, of dealing with it, right? Because you just say, look, this is for closed system, this one is for open system. Then there you go, nothing to talk about. Now, the problem with it is that how would this argument change, therefore, if people stopped? So let's assume, for example, that everybody agrees with Bart K. Okay, so that everybody agrees that the statement he's making of the first law is a correct one. So what if then they say that they are not anymore using or invoking the first law of thermodynamics, but some grander principle, which actually, to be honest, you will find in many physics textbooks, which has to do with simply energy conservation. And you can view it in a very general form, like going even to general relativity and talk about momentum energy tensor that you would trace over through some kind of local region of space-time which is big enough, and so on. It's even also valid also within like quantum field theory and so on. So it's kind of a strong kind of thing that can be stated by some people within physics. So the point is, what if people stop using the first law, invoking it, and then invoke something else that they are going to say, oh, energy conservation. So in my opinion, the problem with this is that the argument that is currently used by Bart essentially falls short of answering this aspect. So as soon as there is a change in the defense position, then essentially you need to change entirely the counter argument. So if I were to phrase it, I would say that the problem with the argument being presented by Barth, which is again completely valid and definitely destroying most of the cases being made, is that is predicated, sorry, on a very specific formulation on the first law of thermodynamics, which on top of this does not allow for any kind of variation as well. So it means that if they are more permissive, if you will, formulation of it, then not engaging with them is problematic, because again, it's going to have this very strong focus on this very specific formulation of the first law. So the second line of argument, which is the one I've tried to start a little bit in the previous video, and that also people like Jason Fung I've put forward, is that actually it does not matter whichever law of physics people are going to invoke, it's never going to ground any kind of physiological law. And that's the point I want to make. So how would that work? Well, let's take, for example, well, two cases of somebody stating some kind of ground physical law. So let's say that there is some law which has to do with conservation of mass. And I know that some people on the webs I've used this particular law to justify kind of CICO or something. And then in that case, this is something along the lines of, mass is not created nor destroyed, and therefore is kind of conserved. So it's akin to Lavoisier's principle in chemistry. So I'm not really committed to say it's a law of physics or chemistry. I don't mind too much tags for it. So what does that mean? Is that the statement that is going to be made is, well, if there is more matter coming in than matter that comes out of a system, then the system is going to have more mass at the end of the day. And that seems to be a fair statement to make, and that's a perfectly valid statement from a physical standpoint or chemical standpoint, depending on where you want to put, in which ballpark you want to put this particular principle. Now, you can do the same with energy and say, well, energy is neither created nor destroyed. It can basically, it's conserved. And then say that the energy that comes into, if there is more energy coming into the system, to a system, than energy coming out of it, then the system is going to have more energy at the end of the day. And that's again a perfectly valid statement to make. Now, the point here is that this statement is completely agnostic as to what happens to the internal workings of the system in terms of how it's responding to the energy surplus. So it doesn't say anything about how this is accommodating this energy. And therefore it says nothing about, for example, change in composition or anything like this. So it's quite easy to see here that essentially there is a statement that is actually applicable to everything, actually contrary to what we would think, has this tendency to underdetermine what's going to happen to more specific systems with much more intricate concepts such as molecule, biomolecule, physiology, etc. So that's basically the idea. Now, there is an interesting what I wanted to discuss now, after having reviewed these kind of different things we are allowed to say in physics and how it's under basically determining anything related to anything else but ground claims. Then what I wanted to look at is basically what is, according to me, what would be the kind of mistake that CICO proponents would make when they try to invoke physics as a rationale for CICO? And I think here, and again, I'm trying to be as charitable as possible, I think that the claim they are making is that essentially biological systems are made of matter, and matter is a subject of inquiry of physics. And therefore, biological systems are subject to or need to abide by the laws of physics. So of course this is admitting that so this is fairly uncontroversial, but of course people could even disagree with this, and that would be fine. But let's stick with this idea here. Now, even if we accept this, that biological systems need to obey the laws of physics, now how do we translate that into some kind of logical argument? Well, the way it is translated is basically that, again, that biology is constrained by physics. That's kind of a crude way of saying it. And there seems to be at least a conflation between claiming that biology is constrained by physics and saying that biology is grounded in physics. Now, the problem with this is that, like the word grounding or grounded, when people use, this word in argumentation, if you ground an argument A in an argument B, or in a theory or fact B, then what happens is that you're claiming that B is going to support A. Okay, that's the reason why you're invoking it. But the problem here is that's not really what's happening. We are saying that actually B is constraining A, but we don't know whether it's supporting A in any shape or form. We know that it's going to constrain how A is going to happen, but that's it. And that's really a different thing to say. My suspicion is that what happens is that there is a kind of logical mistake which is being made here. And this logical mistake has to do with a misunderstanding of how the so-called conditional connective works in propositional logic or in first-order logic, basically what is called classical logic. And the way it works is essentially if you've got a statement that says if A then B, okay, what it means is that if A is true, then B is true. Okay, that's really what it means. If A is true, then B is true. But the statement itself doesn't say what happens if A is not true. Okay, so what that means is that if A is not true, then B could be true, or if A is not true, then B could be not true. So that's what you want to do here. Now, if we talk about CICO, which is a theory or doctrine or paradigm which is being used in physiology, then this is that is basically that need to obey the laws of physics. Then what we know is that actually CICO, if CICO, then the laws of physics. Okay, because there shouldn't be any scenario where CICO is true and the laws of physics are false. And the only possibility for that to happen in an if-then statement is that if we phrase it as if CICO is true, then the laws of physics are true. Okay, and that's the mistake they make, is that they claim that this is the other way around, that it's an entailment, like if the laws of physics are true, then CICO is true, which is not the case. But that's something very common where we believe that the grounder principle that should apply to everything is actually the one which is on the left-hand side of the conditional, of the if-then statement, because it has a causal, at least some form of causal relationship to it. But actually, no, that's not the case. So here in this specific case, from a logical standpoint, it needs to be on the so-called consequent side of the if-then statement. And therefore, then in that case, there is absolutely no problem with, basically the CICO argument disappears. But you see that I have not focused on any kind of physical law. I've just stated that the way the conditional should be phrased is if CICO, then the laws of physics. And we clearly see when we phrase it that way, that basically it's saying nothing, right? That's what we're saying. It's saying absolutely nothing about how the laws of physics are somehow going to ground the antecedent. So that's one thing. And I would like to essentially try to provide an analogy as to why I believe really that the laws of physics are completely underdetermining what's going on in biology. And so the example I have in mind is, let's say you want to play chess. And to play chess, at least in real life, you need to have, well, an opponent in front of you, and then you need to have a chessboard. The chessboard is going to be made out of some material. Apologies for the sound. So it's going to be made of some material, and then you've got the chess pieces. And you're going to put these pieces on the board, and both the board and the pieces, and also the motion you're making to put one piece in from one place to another, all of these things are going to obey the laws of mechanics. Okay, so they are all always going to obey the laws of mechanics. Now, does that mean that because obviously the way we are going to execute the various moves is constrained by the laws of physics, does that mean that the rules of chess are grounded in physics? No, it doesn't mean that at all, right? So there is a linguistic distinction between constraining and grounding. And I think this example does clarify it very well. So obviously the rules of chess are whatever they are, and it are completely independent on the laws of physics. In fact, we can even think of changing the physical substrate and play on a computer. It's still going to abide by the laws of physics, but the rules of chess are unchanged, and they are completely independent of the physical substrate being used. And so here that's the case, because we talk about chess here, and it's obvious in the game of chess that the rules of chess cannot be deduced from the laws of physics. So imagine chess is a somewhat complicated and complex game, but imagine for a human body. I mean, living organisms are incredibly more complicated than a game of chess, and human organisms as well. And so there is absolutely zero reason to think that it's possible to ground any kind of the physiological rules which are going to govern, for example, body composition, and to ground them solely on physics. That this is just this doesn't make any sense. And so I think that's a point I wanted to make, really, is that people can invoke whatever ground law of physics they want. This is always going to underdetermine the kind of rules or laws that are going to appear, at the biological level. So that's it. I hope this clarified a point and maybe made some kind of new point about these different topic and issues. And otherwise, I'll see you in a later video.